talk about the second section of 5-3, which is the orthocenter of a triangle. Before we talk about the orthocenter, it's important to talk about the altitude of a triangle. And the altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. So I guess obviously every triangle has 3 altitudes because there's 3 angles. But this wording could be pretty confusing. A perpendicular segment from a vertex to the line containing opposite side. So I think the best way is to look at it through a picture. Here you see we have triangle ABC, and we want to find the altitudes here. So we're looking for a perpendicular segment from a vertex to the line. So we're going to start at a segment, or at a vertex. Let's start at B in this case. We're going to start at a vertex, and we need to draw a perpendicular segment, so a right angle to the opposite side. If you notice, the opposite side is the one furthest away from the angle. So in this case, we have AC is the furthest away. So going ahead and drawing in this right angle, and I'm sure I'll be slightly off, but this right angle, I would say, looks like so. We have a right angle. That's a terrible symbol there. And you'll see in just a second why we're doing this, but I'm actually going to extend this segment into a line. And now we continue off, and let's see, we can talk about angle C now. Angle C, if we were to draw a perpendicular segment now, the opposite side would be AB, okay? Now think about drawing a right angle. We could try to put a right angle anywhere in here, and it's just not going to happen. So oftentimes when looking for altitudes, it is necessary to extend the sides of our triangle. Because now if you notice, a altitude at a right angle would almost drop right down, as we now have our right angle there. And how about angle A now? Again, we're in the same boat where you try to draw your right angle in here and it's just not going to happen. So it is necessary to extend our triangle. And now we can draw our right angle. And we'll see our right angle will come in like so. And I could extend the other side if I wanted to. It's not important though. The biggest key here is that we came to one single spot. We have a word for this again. These lines are all concurrent. They come to one point. And of course we have a name for this point. We call this point the orthocenter. The orthocenter is the point where all 3 of the altitudes of the triangles meet. One important note about the orthocenter is that the orthocenter can be on, or rather inside, outside, or on the triangle. In our diagram in the slide before, we saw the orthocenter outside, but we can also have inside or on. So we don't have a theorem or anything. All we have to do really is we're going to find the orthocenter in an example. So we're told to find the orthocenter of a triangle with vertices x, which is at -5, 4, y at 2, -3, and z is at 1, 4. Now, it's not very difficult to do. We're going to follow the same steps every single time, but they will take time to do. So let's look at step 1. The first step says to graph the triangle if needed. And so this is not a required step, but if it definitely helps you, then most definitely do step 1. Alright, graphing this to see what it would look like. We have x is at -5, 4. So we're over 1, 2, 3, 4, 5, and then up 4. So we have our first point in the second quadrant here. Then we have the point y, which is at 2, -3. So 2, -3. Our second point, which we can label as y, and x was our first, and z, which is at 1, 4. So 1, 4, and this is z. So this will help us at least imagine what this triangle looks like. And now we can go on to step 2. Step 2, what we need to do is find the equation of an altitude of the triangle. So we can pick any altitude we want. If you can go back to the other slide, any altitude. But what we do need to keep in mind, and it might help you along through this, is almost as a hint, keep in mind what an altitude is. An altitude is perpendicular. That's a very useful hint because remember, if we remember the equation of a line as another hint, like hint part 2, perpendicular lines have opposite reciprocal slope. Both of these hints are very useful when writing this equation. So let's go ahead and actually do it. I'm going to go ahead and choose, let's see, the point X. So if you look at your diagram, you'll notice that the opposite side is the line segment YZ. So from the point X, we're dealing with the segment YZ. So we need to find the slope of the point, the slope of the segment YZ. So remember, to find the slope, you're going to do y minus, or y1 minus y2 over x1 minus x2. So that's what we're going to do. So we're going to do negative 3 minus 4 over 2 minus 1. And what does that give us? That gives us negative 3 minus 4. Well, that's going to be negative 7 over 1. Meaning we have a slope of negative 7. But this isn't the equation that, or this is not the line we want. We want the perpendicular line. And perpendicular lines have opposite reciprocal slope. So the actual slope we want has an opposite, meaning this is negative, so we're going to have positive, and reciprocal, so we're going to flip this 7. But it's kind of confusing if you think we're negative 7. It's kind of confusing, but this is the same as negative 7 over 1. You'll even see that right there. It's negative 7 over 1. So we're talking about positive, and now flip. Make the bottom go to the top, and the top go to the bottom. So the slope we want is 1 over 7. Okay, we have a slope. Now we need a point. Well, the point that I told you we were going to use was x. And as a reminder, it's in your notes, but x was at the point negative 5, comma 4. So writing this equation, we're going to use point slope form. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. So just plugging stuff in now, we have y minus, what's our y value? The y value of x is 4. So you plug in 4 is equal to 1/7 times x plus 5, because it's going to be x minus a negative 5. Now through all this, you'll notice it's going to be helpful in the future. You're going to want to get this in slope-intercept form, meaning distribute the 1/7 and add 4 over. So we have y minus 4 is equal to 1/7 x plus 5/7. And then we are going to add 4. Plus 4 plus 4. So our equations, it's y is equal to 1 over 7 x plus, we're going to find the common denominator. Just to show your work up here, you have 5/7 plus 4. you need a common denominator, so you're going to do 5/7 plus, well, we need to put this guy over 7. So what is 4 times 7? You have 28. Now we can add. 5 plus 28 is 33 over 7. So we have plus 33 over 7. And although it looks really ugly, this is our first equation. Now we have step 3, which says to find the equation of another altitude of the triangle. So we go along, we found x, the altitude going through x, so we can find another altitude. In this case, I'll just find the altitude through the point y. And so that means the opposite side is xz. We're looking for xz. So we're going to do the exact same steps. I'm going to go ahead and do these just for the sake of time. I'll still follow the exact same steps, and so maybe you can follow along as I write them down. So we went and found the slope of yz. Now doing this, we actually found we had a slope of 0. Okay, that's okay, it just means it's a horizontal line. So then we need to find the slope of the altitude, which is when we flipped the 2. Well, then we saw you're dividing by 0, and we cannot do that. So we have undefined slope. And again, that was because you can't divide by 0. So this means it has to be a vertical line. This goes back to algebra. Any undefined slope is a vertical line. So now you're writing the equation of this line. It is a vertical line through the point y, which is at 2, -3. All vertical lines have the form x equals. Well, x equals what? X is equal to 2. So now we have 2 equations. Now that we have 2 equations, we move on to step 4, which is to solve the system of equations, solve the 2 equations, through substitution or elimination. This should ring a bell because it's from Algebra 1 actually, is that once you have 2 equations, you can either substitute, you can solve for a variable and then substitute it in, or you could try to eliminate a variable. So let's look at our 2 equations here. We have, let's see, we have y is equal to 1/7 x plus 33 over 7, and then it says that x is equal to 2. Well, looking at this, I quickly see that I'm going to use substitution. I know what x is equal to, so why don't I just substitute it in? So I see y is equal to 1/7 times 2 plus 33 over 7. Simplifying that, that's y is equal to 2/7 plus 33 over 7, which is saying the same thing as we have a common denominator of 7 and 7, so we can just simply add the tops, which is 35 over 7, and you can type that into a calculator. That's exactly 5. So I know that y is equal to 5, and I may have to go substitute something else in for a different problem, but in this case I also know what x is. So when we find the orthocenter, all we're looking for is a point, and in this case the point we are looking for is 2, 5. And again, I know these steps can be long and tiresome, but they're not entirely difficult because it's nothing new. So anyway, this is all we need to know about the orthocenter, and we now know how to find it.